5.1 Part 2 continues solving systems, but today we're going to use substitution. When you use substitution, you will be able to either take one of the equations that's given to you where one of the variables is equal to, or you'll be able to take one of them and solve for one of the variables. The expression that that variable is equal to, you're going to plug into the second equation, or the one you're not working with yet, and solve for the variables that you have. So it'll literally eliminate any of the, so for example, if it's y is equal to, and you plug in the expression that has the x in for y, you're going to eliminate the y and solve for x. Once you do that, you'll be able to, like I said, you'll be able to solve for that variable that you're working with. Then you will use that in order to plug it in for the equation that you had originally. So what this all means is, if you look at these two equations, you have x plus y is equal to 4 and x minus y is equal to 2. If we use the top equation and we solve that for x, we're going to have x plus y is equal to 4. We move the y over by subtracting it from both sides. That gives us x is equal to negative y plus 4. We will now take this negative y plus 4 and plug it in for x in that second equation, the one that we haven't worked with yet. So when we do that, that's going to give us negative y plus 4 minus y is equal to 2. So just that negative y plus 4 is what we plugged in for x. From here, combine your like terms. That's going to give you negative 2y plus 4 is equal to 2. Move your 4 over by subtracting it from both sides. You get negative 2y is equal to negative 2. From here, you're going to divide each side by that negative 2. And then y would be 1. So the 1 you're going to plug in for y, and that x is equal to negative y plus 4. And that's going to give you x is equal to the opposite of 1 plus 4. So that's negative 1 plus 4, which gives us 3. So your x is 3, your y is 1. That's the ordered pair 3, 1. For your next example, you have for a, y is equal to 2x plus 3, and y is equal to x plus 5. So use that second equation, take the x plus 5, plug it in for y, and solve for x. So that's going to give you x plus 5 is equal to 2x plus 3. Move your 2x over. I'm going to subtract it from both sides. That gives us negative x plus 5 is equal to positive 3. Then you will subtract your 5 over, giving you negative x is equal to negative 2. Then divide each side by the negative 1 to make x positive, and that gives you x is equal to 2. If x is equal to 2, pick one of the two original equations, plug it in for x, and solve for y. I'm going to use the bottom one just because it's easier. So we have y is equal to 2 plus 5. The 2 plus 5 gives you that y is equal to 7. So if your x is 2 and y is 7, your solution is the ordered pair 2, 7. For example B, we have 2x plus 3y is equal to 8, and y plus 2x is equal to 6. The first thing we're going to do is we're going to look at that bottom equation. You have y with a coefficient of 1. So because there's not a number in front of that y, it's going to be the easiest equation to use in order to solve for one of those variables. So we'll use that equation, that bottom equation, to solve for y. And we're going to just move the 2x over by subtracting it from both sides. And that gives us y is equal to negative 2x plus 6. So now that we have what one of those variables is equal to, we're going to use that expression, the negative 2x plus 6, and plug it into y in the top equation. So that's going to give us 2x plus 3 times y, which we said is negative 2x plus 6, is equal to 8. We will distribute the 3 in first, giving us 2x minus 6x plus 18 is equal to 8. From here, combine your like terms. That's negative 4x plus 18 is equal to 8. From here, subtract your 18 over. That gives you negative 4x is equal to negative 10. Then divide each side by the negative 4. Simplify your fraction, and x is equal to 5 over 2. Now that you have what x is equal to, plug that in for y. You can use the y is equal to negative 2x plus 6. So that's going to give us y is equal to negative 2 times 5 over 2 plus 6. Your negative 2 times 5 over 2 is going to give you a negative 5 plus 6. So that gives you a y of 1. Since y is 1 and x is the 5 halves, your ordered pair, that is your solution, is 5 halves, comma 1. For example C, we have 2x plus 3y is equal to 5 plus x plus 4y, and y is equal to x minus 5. Anywhere where I see a y up top in that first equation, I can plug in that x minus 5, or I can simplify that top equation first by combining like terms and moving my terms around, and then plug in that x minus 5 in for y in that top equation. So that's what I'm going to do in your completed notes. And here, I'm going to actually just plug in the x minus 5 anywhere I see the y. So that way you see it done two different ways. So if we do that, we're going to plug that x minus 5 in for this y as well as this y and simplify with that in. So it's going to give us 2x plus 3 times y, which we said is x minus 5, is equal to 5 plus x plus 4 times y, which we said is x minus 5. First thing I'm going to do is distribute the 3 into the x minus 5, as well as distribute the 4 into the other x minus 5. So that's going to give us 2x plus 3x minus 15 is equal to 5 plus x plus 4x minus 20. From here, I have an x on both sides that I can combine. On the left side, I have 2x plus 3x, which gives us 5x minus 15. On the right side, we have x plus 4x, which is 5x. We also have the 5 minus 20, which is negative 15. From here, if we move the 5x over by subtracting it from both sides, it cancels out on each side. So we have negative 15 is equal to negative 15. When we have the same number on both sides of that equal sign after our variable term cancels out, we have infinitely many solutions. This is a true statement, so our answer is automatically infinitely many solutions.
Are we going to have a question like this?
You might. If you get a true statement like this and we say that it's infinitely many solutions, on the contrary, if you get something that's a false statement, so your two variables that you're working, or the variable that you're working with ends up canceling out, and you get something like 2 is equal to 6, that's a false statement, so it would be no solutions. So just like I said, the opposite of this. For example, D, we're given x minus 2y is equal to 3, and 2x minus 4y is equal to 7. The top equation is going to be the easiest to solve for that x. So I'm going to take that x minus 2y is equal to 3 and just move the 2y over by adding it to both sides. So that way my x is by itself. So I get x is equal to 2y plus 3. Now that I have what x is equal to, I'm going to take that 2y plus 3 and plug it into the x in the second equation. So that's going to give us 2 times 2y plus 3 minus 4y is equal to 7. Distribute your 2 into the 2y plus 3. That leaves you with 4y plus 6 minus 4y is equal to 7. You have like terms with the 4y's. They are opposites, So they cancel out, and you are left with 6 is equal to 7. Now in this one, the 6 is not equal to 7. So since this one is a false statement, you have no solutions for this one.